CompTIA Tech Complete Training Course. Exam Objective 4.4 Identify Programming Organizational Techniques and Logic Concepts. For loops. For this video segment, we will discuss for loops. A for loop is a programming construct that is very similar to a while loop, but they differ slightly in their structure and application. Both loops repeat a block of code, allowing for efficient automation of repetitive tasks. The key difference lies in their decision mechanisms. A for loop, as pictured on the left, typically specifies the number of iterations prior to execution, making it ideal for situations where the number of iterations is known in advance. On the other hand, a while loop, as pictured on the right, relies on a condition to control its execution, making it more suitable for scenarios where the number of iterations is uncertain. Now that we got the flow of things, let's take a look at a for loop using some pseudocode and walk through the code line by line. Our example will demonstrate a for loop which specifies a counter variable, I, along with its start and end values. By specifying the start and end values for I, we are designating in advance how many times we want to iterate through this for loop using integer values. This example will also include the keyword, next. A next statement is used in certain languages to increase the counter variable by the value of 1 each time the loop completes an iteration. Ready to walk through this example line by line? Alright, let's go. First up, we will declare a variable with the identifier y and initialize it with the value of 4. On line 2, we see a for loop statement. The for loop statement starts with the word for. This is followed by the declaration of a counter variable. For this example, our counter variable will be I. This variable is appropriately named as it will help us keep count of which iteration of the loop we are on. Next we have our start and end values. With this statement, we know that we will continue this for loop from the time our counter variable I starts at 0 and continue until our counter variable I reaches 2. Being that this is our first iteration, our I variable will be set to the value of 0 for now. The indented code statement on line 3 is part of our looped code. It will reassign the variable y with the current value of y plus 1. Y will now be set to the value of 5. On line 4, we see the word next. This next statement will increase the counter variable by the value of 1 and mark the end of our loop's first iteration. Now we head back up to line 2 and start the for loop all over again. Since the value of the variable I, which is currently 1, is still in the range of 0 to 2, we will iterate through the for loop again. On line 3 we will reassign y with the current value of y plus 1, making 6 the new value. On line 4, we see the word next. This next statement will increase the counter variable by the value of 1 and mark the end of our loop's second iteration. Next, we pop back up to the top of the for loop again. Since the value of the variable I, which is currently 2, is still in the range of 0 to 2, we will iterate through the for loop again. On line 3 we will reassign y with the current value of y plus 1, making 7 the new value. On line 4, we see the word next. This next statement will increase the counter variable by the value of 1 and mark the end of our loop's third iteration. Now, this time when we pop back up to the top of the for loop, since the value of the variable I, which is currently 3, is no longer in the range of 0 to 2, we will not iterate through the for loop again. Instead we will continue on in the code with the next line following the for loop, which is line 5. On line 5, we will reassign y with the current value of y plus 5, making 12 the new value. We also no longer retain the counter variable I in memory, as we have finished with our for loop. Next on line 6, we see the word echo. Echo is a word used by some programs to perform an output. In this case, our program is called to output the value of y, which is currently 12. And with no more lines of code, our program ends. Now, if you ever feel like you're stuck in an infinite loop of confusion, just press pause, grab a snack, and debug your frustrations before diving back into our video series. Thank you for watching. Subscribe for more great content.